Welcome to the final Trig word problem lesson. So what we're going to do today is we're going to look at all of the tools that we picked up in all of the trigonometry units that we've looked at this year, and then we're going to tackle some questions and make decisions on, which tools should we use. Some of the questions you might actually need to use both. Because you'll have both types of triangles and so forth. But yeah, anyway, so that's what you just need to make those decisions today depending on what information you're given, okay? So when you're going about solving triangles, so you can kind of use this flow chart. You can modify it a little bit, but you can use this flow chart here. So it comes down to when you look at a triangle and you need to find some information that's missing, you have to ask yourself, do you have a right triangle? Those are the ones that we studied initially, so it has a 90-degree angle in it. Otherwise, you have a non-right triangle that you need to deal with. So if you do have a right triangle, you're going to be looking at using the ratios SOHCAHTOA or Pythagoras. Okay, so I've gone through and written in the equations. So again, if you have a triangle problem that you have to solve and you know it's a right triangle, you're going to go down this part of the flow chart. And if you know you have two sides, okay, if you have two sides, then in order to find that last side, you can use Pythagorean theorem, okay? So that's that a squared plus b squared equals c squared. Equation, okay? And then again, remember that the C is always across from the right angle. That's the biggest angle, so you have the longest side here, okay? So that's important. Don't just kind of randomly label things A, B, C, okay? All right, if the clues are, though, that you only have one side and one angle, okay? So if the clues are you have one side and one angle, and then you have to find a side, okay, then what you want to do is you want to use SOHCAHTOA here. Okay, so SOHCAHTOA is sine, theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, so you're going to use these, filling the angle in and one of the sides in solving for the missing side, okay? And then if you had a right angle triangle and you had to find the missing angle, you can do that by, again, using SOHCAHTOA, but then in the last step, you're going to have to throw the sine or the cosine over and use the inverse sine, cosine, and tangent functions, okay, in order to find the angle. So just a reminder, when you have a right angle triangle, remember you stand by the important angle, okay, you look in, and so that will be the opposite side here. The longest side across from the right angle is always the hypotenuse, and this is the adjacent. Okay. All right, and then so that's what we covered. So this is the one where you have to find the angle. Okay, so find the angle. Given one side and one angle, or you might be given a couple of the sides. Okay, so yeah, so this is the one where you find the angle. Okay, so then recently we looked at what to do when we don't have a right angle triangle. So we have a non-right triangle or an acute triangle. So we'll have, a triangle that looks something like this. So we'll label it ABC. The sides that are across from that angle are labeled with lowercase letters, like that. Okay, and so from there we use a couple different formulas. There's the sine law and there's the cosine law. So here it's telling you about how if you have one side and an opposite angle, use the sine law, right? And then if you don't have that, use the cosine law. So we were trying to learn or memorize these ones by, okay, if it's sine law, then you're going to have angle side angle, or angle angle side, or angle side side. Okay, so whenever you have those given pieces of information, use sine law. And then cosine was where it was side, 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 or side, angle, side, like that. Okay, so that's when we use the cosine law. Here's one of them, and then here's the equation rearranged so that it's easier for you to calculate out the angle. Okay, so we're going to go through here and just look at some examples. We're not going to actually solve them, but we're just going to look and state what tool from above here that you would use in order to um, go about solving this problem. Okay, so here, you need to find the side y here. You have a couple of the sides, and you have a right angle triangle. So in this case here, whenever you need to find that third side, you can just use a squared plus b squared equals c squared, right? So that's Pythagorean theorem. All right, and so and if you try to use SOHCAHTOA, you need to have one angle, so you won't be able to find that last side without that angle. Okay. All right, so here's the next one. Find M. So we need to find a side. We are given a side and an angle. Okay, so here I would use SOHCAHTOA. Okay, so I'll call SOHCAHTOA these ones here. Okay, so these primary trig ratios. All right, and so again, you would stand here. That's the opposite. That's the adjacent. Okay, we don't have the hypotenuse, so I would use the tangent ratio. Okay, all right, and to the next one, we need to find the missing angle here. So again, we know it's a right angle triangle, so you're going to stand here. You can label the sides, right? And this is the opposite. This is the adjacent. So again, we have a tangent, so we're going to use SOHCAHTOA again, but specifically we're going to use tangent because we have the opposite and the adjacent sides. Okay, that's why we have the OA here. But then eventually, because we have to find the angle, you're going to have to eventually get to the inverse tangent when you solve your way through the question. All right, this one here, we didn't have it up here, but hopefully you can see that there's two triangles within each other. They have so again, if you were to draw them separately, there's the big one, there's the little one, so they both have a right angle in this corner here. The picture's saying that these are the same here, and then see how they share this corner here, so really this corner angle is the same as well. So because you have the exact same angles here, but you can tell that they're definitely not the same size, you have similar triangles here. Okay, so when you have similar triangles like that, you know that you can use, so the angles will all be the same, but you can use the ratio of the sides. So here, this is what we do. We would go, so like if we label this again, H, L, J, that's the big one, and then the little one is I, J, K, like that, okay? So H, L would stack up with I, K. H, J, that's the hypotenuse here, the long side here, is forms a ratio with IJ. And then last side, LJ, that's the bottom here, is KJ, like that. Okay, so yeah, so you have the proportional ratios here. So again, if you know some of them here, you can go and find the unknown, like this X here. Okay. All right, last two. So again, you're always looking for, do you have a right triangle? Okay, great. So then you can use one of these. But here, when we had a couple of them tucked in, you knew that the angles were the same. Then this is the similar triangle rule. All right, and these ones here, so see how there's no 90-degree angle, and even if we check this one here, so it's like 40. So if we take those away from 180, this last angle is 75. So this one I can't tell what the angles are, and this one I can't either. So it's basically because we don't know there's a 90 degree or not. So we're going to go with that these are non-right triangles, so acute triangles. So we need to use the sine law or the cosine law. So the way we're going to figure out what to use is that we're going to look at what information we have. So right now we have an angle here. We have an angle here, we have a side, right? And then you can even say like you have another angle here that you found, okay? Here we have an angle, side, an angle like that. These ones here, we have a side, we have an angle, we have a side. Now in this one, side, 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 okay? So right now we have side, 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 and we had a side, angle, side here. And then for this one here, it was angle, angle, side. And then this one was angle, side, angle. Okay, and then I could have had another one there. That would have been this one here, okay, the one that squares. So whenever you have these clues given to you, you're going to use the sine law. Okay, because we know they're not right triangles. And then, yeah, and then these ones here, whenever you have these clues here, you're going to use the cosine law. Okay, so that's one of your checkpoints today, where I'm just going to give you some triangles and you just tell me which method would you use. Okay, you don't have to solve them. Okay, but today what we're going to do is we're going to go through a few more examples of using some more advanced word problems, and yeah, then from there there's going to be a checkpoint on word problems, and then there'll be another checkpoint just separately on just identifying the methods. So feel free to do whichever one in whatever order, and then yeah, just hand them in, and then that's it. We're done for the year. Example 1: Reed is in a hot air balloon directly above a highway. Reed is looking west. Okay, so let's get our little compass drawn here. Okay, so it's looking west at an angle of depression of, so just let's get a diagram drawn here. Okay, so there's a hot air balloon 750 meters above the highway here. Okay, so you're up in this balloon, you're looking west, which is this way. Okay, so you're looking straight ahead west. And then you're going to look down at an angle of depression of 75 degrees. Okay, this diagram is not going to be to scale, okay? All right, so 75 degrees here, and then you are 750 meters above the highway. All right, so hot air balloons here. Okay, so this is exit 85. Okay, so again, you look straight ahead. Your eyeball is here. So let's pretend your eyeball is looking right there, looking this way. And then you look down, and when you look down, this is 75 degrees, okay? And then looking down at exit 85. All right, so exit 83 is located 2 kilometers away. So here is my 750 meter height of the air balloon, okay? So 2 kilometers away is 2,000 meters. So let's just switch everything to meters here. All right, so so that's like looking this way. So 2 kilometers away, exit 83 is over here. Okay, so exit 83 is located 2 kilometers east, so this way, because east is this way, of exit 85. So we need to determine the angle of depression. So again, if we were looking this way now, looking east, we need to figure out the angle of depression. So this angle here, when we look down at exit 83, okay? Okay, so some other things to add here. So since we know this hot air balloon is straight up from the highway, we know this will be 90 degrees there. Oh, we forgot to write this distance from, exit 85 to exit 83 is 2 kilometers or 2,000 meters. And what else do we need here? Yeah, I guess that's it. Okay, so let's go through and determine, yeah, just kind of get a plan organized on how we're going to go about solving this. Okay, so our given information, what we need to find is theta, okay, or you can call it x. So that's the angle of depression here for when you're in the hot air balloon and you look down at exit 83, okay? All right, so so again, you can try to use all the different tools that you picked up, okay? So in the end, so you can get to your answer here. So so right now, you know that, down here, this is 90 degrees. You know along here, that's 90 degrees. Okay, so if you, when in doubt, like when you don't know what to do, just start kind of finding some stuff here. So we know that there's a 90-degree angle up in this corner here. So if we know this is 75, we can say, oh, well, then we know this is 15 degrees here. Okay, all right, and then yeah, and then if we just keep kind of looking around, okay, that's 90, so this would be 75 as well, because angles in a triangle add up to 180. Okay, so what we're going to do here is we're going to try to use all the different tools that we know in order to attack this question here. So our goal here is to figure out this angle in the end, okay? So far, we know 75, we know 15. So if we could figure out this angle, we know this whole angle here adds up to 90, right? So if we could figure out this one, we can, subtract it from 90 and get to here. So what we see here is we do see a big acute triangle, okay? We see some right triangles as well. So in this first one on the left, you know that it's 750 meters high, you know the angles inside of it. So since you have an angle and a side, you could find, the two remaining sides here. Okay, so we do know the distance at the bottom of this big triangle here, right? So it would be good to know the length of this side here. Okay, so if we could find the length of that side, then what we can do here is then we can move to the big triangle here. And so like if we knew what x was, we know that the bottom of this one is 2000. And then we know this angle here is 75 degrees. So in this one here, so again, because we can use SOHCAHTOA here, because we have a side and an angle. And then when we get to here, we have, like we'll have this side, we'll have this angle, and we'll have this side. Okay, so we'll have a side angle side. That means we can use the cosine law. Okay, so the cosine law can help us find, another side or another angle and so forth. Okay, so but if we're going to find the angle, we do need all three sides. So we could find this side here. So we'll call this side y. Okay, so with cosine law, we could find this this side here. So that's the big side of that triangle. All right, so but if we look at it just with that little right triangle inside here on the side, so what do we have? Well, we know that this is 750 meters this way. We will go through and solve it and figure out this side here, which is going to be side y. And then, that's all we know. We know we don't know any of the angles inside of this little triangle on this side, okay? So, but what do we have? We have two sides, okay? So if we have two sides, we could find an angle inside, and this is again using SOHCAHTOA. Okay, so we could find this angle in here. I don't know, we'll call it Z. Okay, so we can use SOHCAHTOA in order to find missing angles when we have two sides like that. Okay, we just need to, eventually use the inverse in order to get to the angle that we need. Okay, all right, so if we can, find x and then find y using cosine law and then using SOHCAHTOA, the trig ratios, we can find side y. So we could find this side here. So once we do all of that, we can find the angle in here. Okay, and so if we find the angle in here, we know that these add up to 90. Okay, this whole corner here should add up to 90. So we should be able to figure out our final answer here, this angle of depression for exit 83. Okay, so lots of steps, but again, this is just applying everything that you've learned this year now. So let's just kind of go through and put all of our plan into action here. Okay, all right, so we're going to start with the first one here. We have our little triangle here. We need to find this side here. Okay, so in order to do that, you do the usual. You stand at an important angle. So we know both of these. It doesn't matter which one you stand at. So I'm just going to grab this one here. So looking here, looking in, this is your opposite side. Okay, this is your hypotenuse. Okay, so, and the last side's adjacent here. We know that we need to find the hypotenuse. We do have the opposite side. Okay, and then we see that the sine ratio is the one that we have two check marks for, so we need to use the sine ratio here. Okay, sine is opposite over hypotenuse. That's why it's O in the little abbreviation here, okay? All right, so the angle we're standing at, that we decide to stand at here is 75, so we're going to use that one. If you stood at 15, then use 15, okay? All right, the opposite side is 750 divided by x, okay? And then again, remember how whenever the x is at the bottom, just make your life easy, just flip them both. So it's a lot easier to solve. Okay, it's a little hard when the x is at the bottom. Okay, all right, so we flip them both, and then we're just going to toss the 750 over there. See, it's divided right now. I'm going to multiply it over there. So 1 times 750 is 750, and then divided by sine of 75. So when we do that, we will get 776.457, etc. meters, okay? All right, so that is now your x value here, okay? So we can even write that in here. So this is now 776.5. I'm out of space, so I'll just get around it there. So that is still, like, again, it's this side of this triangle. So it's also this big side here, or this side of this big triangle. So this is 776.5 meters, okay? All right, so we use SOHCAHTOA to find that piece there. So now we're going to use the cosine law, because now we have a side, we have an angle and a side. So we're stepping out now and looking at the whole big triangle here. Okay, so we know this side, we know this side, we know the angle. So with the cosine law, we will be able to find this third, or the side here, okay, that's across from the 75 degrees, okay? All right, so let's just go through and, label it ABC. So I'm just going to circle the side angle side so it's not confusing here, okay? All right, so I'm going to label this ABC. So I'm going to call this A, B, and C, like that, okay? So, sorry, it's getting messy. I'm just running out of space here. So A, this is little a, right? C, this is little c. And B, this is little b, okay? So if we go through here, and I'll just keep writing in purple here, we need to find side little a. So we're going to use this formula here. This cosine formula here, in order to find side A, which is actually our y. Okay, so cosine A. All right, so if we go through here, and so A, we don't know it, so keep writing that. All right, B is 2,000, so we're going to square 2,000 here. And C is that new value that we found, but we're going to carry a few more digits, right? We're not going to round it early on, so we end up messing up our final answer, okay? All right, add 2 times B, which is 2,000, times C, which is this 776. All right, and then cosine 75 degrees. Okay, so I'm just going to go through and calculate that out and then get to our answer. Okay, so I went through, plugged everything in. There's B, there's C, B times C, and then cosine A. And then just, carefully went through and calculated it out, okay, and then combined it, and then you should get this number once you calculate all this out. All right, and then from there, we're going to boot this square over this way to solve it. And when you do that, it becomes a square root, and then you get this value for A here. Okay, so now we have this large value here for the distance here. Okay, so if we're looking down from the hot air balloon here, looking down at exit 83, we now know that distance. Okay, so that again can go on this triangle here. All right, so once we know that, we have a couple sides, so now we can use SOHCAHTOA again in order to find the angle that's in here. And then I know that's not the last step, so eventually we will get to our last step here of finding theta by taking 90 and subtracting by z. Okay, so that's our last goal. So I know lots of steps here. Okay, so we need to use SOHCAHTOA here in order to get to our z, our angle z, okay? So we're going to go through here, and add in. Okay, so we're, again, the important angle that we're standing at is here. Okay, and then we have, this is the opposite side. That's the adjacent side. And this is the hypotenuse that we just found, okay? All right, so from there, we need, okay, so we have adjacent, we have hypotenuse. Okay, so here we're going to use the cosine ratio in order to find our z value here, okay? So we are going to, cosine theta is adjacent over hypotenuse. Okay. All right, so we don't know the angle, so it's z. And adjacent is 750, and the hypotenuse is that 1,949. I'm going to use all the digits from the last question here. Okay, and there it is. So we'll keep going down here. All right, so in order to get z, we need to boot the cosine over. So when we do that, think of it as the opposite of cosine is the inverse cosine. So you're going to take the inverse cosine of 750 and so take those here. Okay. All right, so when we do that, so we'll get so inverse cosine 750, you will get 67.3692, etc. Okay, so this is the angle that is now in this corner, which is right here. So if you wanted to write that in, right there. Okay, so we found now 15, and this part here is 67.369 degrees, okay? So now we can get to this last one here we know this corner here is 90 degrees, so we're just going to take that value we just found and subtract from 90 degrees, okay? So theta, so here we'll put it here, theta is going to be 90 minus z, so that's what this is here, 90 minus 67.3692, etc. And we will get 22.63 degrees. And we wanted to have this to the nearest degree, so we need to round it to a whole number, so 23 degrees. Okay, so yes, it was a lot of work. We threw all our tools at it, a lot of tools. Okay, we used SOHCAHTOA, and then we used cosine law, and then we used SOHCAHTOA again, but then we had to take the inverse to find the angle, and then we even took stuff from elementary and grade 9, where angles in a corner, I guess an L shape here, add up to 90 degrees. So knowing that, we took that new number we found here and found that the angle of depression from the hot air balloon looking down at exit 83 is 23 degrees. Okay, and here's our last statement here. So the angle of depression from the balloon to exit 83 is 23 degrees. Okay, so we're going to continue with some more trig problems here. Again, we're looking at directions on a compass and so forth, so it just gets a little more complicated, so I just wanted to point out, kind of practice with you here what you need to do here. So directions are often stated in terms of north and south on a compass, okay? So you'll see things like, N 30 degrees E. Okay, so what does that mean? So you are traveling 30 degrees east of north. So basically, where north, east, west, and south are. So compared to where the north is, if it says 30 degrees and then east, so that means you are going east in the east direction, but you're going to make a 30-degree angle. Okay, so that's where north 30-degree east is, okay? And then here, if it's, S 45-degree W, so south 45 degrees west, so that means you're starting at south, right? And then you're moving westwards, so which is this way. Okay, so this way would be east, this way is west. You're making a 45-degree angle. So when you do that, that's where the angle is, okay? So just keep that in mind, kind of keep referencing this as we're doing the next example here. All right, so we have a captain here, and leaves a marina and heads due west. Okay, so again, west is this way for 25 kilometers. Then the captain adjusts the course of his boat and heads north 30 degrees east for 20 kilometers. How far is the boat from the marina? Okay, so let's draw our diagram out here. Okay, so let's just say our marina is, okay, so we headed west, right? So we went west and then you had to adjust and go north um, 30 degrees east, okay? So maybe we'll put it down here. So we headed west, okay, this way for 25 kilometers. And then, so if we had, okay, so this is where the marina is. Okay, so you headed 25 kilometers west. And then, so now if we made a north, kind of a compass right here, okay, so what the captain ends up doing is making an adjustment, and now he's heading north 30 degrees east. So remember, this is north up. This is north this way, right? So this is north. So if you were heading 30 degrees east, east is this way. So you're going to head like that. So this is 30 degrees in here, right? So if our compass was still here. So you're heading now north 30 degrees east. That's what this is here, okay? All right, so then, oops. Okay, so it's kind of like what we did here. So we went west from the marina and then adjusted and then went this way. And now it wants, you need to figure out, well, how far are you now from the marina? So this is this part here. Okay, so knowing that, you need to go through and solve this problem using your different trig tools. Okay, so I forgot to add this 20 kilometers here. Okay, so we went 25 west, then 20 kilometers north, 30 degrees east. Okay, and then we need to find this distance here. All right, so if we look at this separately, or I guess we can look at it together here. So right now, see how this is like a right angle right in here? So we know that this here forms a right angle. So we know this part of it is 30. So the rest of it has to add up to 90. So we know that this angle in here is 60 degrees. Okay? All right, so what do we have? Well, we have I'll do it separately. So we have 60 degrees here now. We know this is 20. We know this is 25. And our goal is to find this side here. So what we have here is a side angle side. We know that we don't have a 90-degree right triangle, right? So we have so we have a side angle side. And what is the side angle side lead to? Okay, so we can use this points us towards the cosine law. Okay, so we can use the cosine law in order to find that missing side here. Okay, so once we find that, then we have our answer. All right, so let's go through. So this is a lot simpler than the one we just did. Okay, so I don't know why I started off with the shop one, but I know you guys can handle it. Okay, so this all gets working here if we can label the sides. So I'm just going to redo that here. Okay, so we can call this, I don't know, we need to find this side here. So we'll call this A, B, C. So this is little a, this is little b, and that's little c. Okay? All right, so let's get to the cosine law. So we're going to use this one here to find side A. Okay. All right, and then just fill everything in and then check your work. Okay, so we went through and plugged in our cosine law formula here. And we were careful, we calculated everything correctly, and we calculated out 525 from here. And then remember, we're going to kick this square over this way to square root this side, and then we get a value of 22.9, okay, in kilometers. Right, so therefore the boat is that 22.9 kilometers from the marina now. Okay, so if it took a path of 25 kilometers west, and then it changed directions and went north 30 degrees east, that's what you do. So it's kind of like this new thing that you picked up is kind of like it's a new angle of depression or angle of, elevation and so forth, right? So just another tool that you can use going forward into, other math classes and science classes and so forth, okay? All right, so again, start off with drawing yourself a diagram, writing out everything that you need to know, all right? And then, state what it is that you have to find. Well, I have to find that side here that determines how far you are now from the marina, all right? And then you kind of put a plan together here. Okay, so we knew that we could find some information here because there's a 90-degree here and find that angle, and then we knew we had side angle side, so we're going to use cosine law. All right, and then from there we put it into action here. We're careful, and then made our therefore statement at the end. All right, example 3. Here's another one with some compass directions here that we have to sort out in order to draw the diagram. So we have a couple ships that leave a dock at the same time. One travels a certain speed, and on this course, south 75 degrees east, and the other one travels 15 kilometers on a course per hour on a course that's south 55 degrees west. Okay, so let's get our compass drawn out here. Okay, so we know that this is south. Okay, and so we need to just kind of look at what this means. South 75 degrees east. Okay, so remember, it's all compared to either north or south. So in this case here, it's south, and then we're going 75 degrees east. East is this way. So what we're going to do is we're going to create an angle in here, like this way, that is south 75 degrees east, like that. Okay, so the angle right in here is 75 degrees because we went eastwards. All right, and then the other boat does this where it's going south 55 degrees west. West is this way, so that means, okay, this isn't to scale, sorry, but that means the boat went out 55 degrees from the south, okay, direction, and is now traveling south 55 degrees west. Okay, so now that you kind of can visualize what that looks like, they're leaving from the same dock, okay, and they're traveling at different speeds here. So we need to figure out how far they would have traveled. So basically, we have different speeds here. So they're going to keep going and going and going, and at some point at 4 hours later, so like we were looking at 4 hours later, we're just going to check right now and see how far apart they are. Okay, how far apart they are. So obviously, because they're, I guess this one's traveling a little faster, so it's gonna get further out, I guess. So there we go. So something like that. Okay, so, and then, this one's got a bigger angle to go out too. So anyway, in the end though, at 4 hours, we're gonna stop and check and go, oh, okay, how far apart are they now? Okay, so yeah, so let's just draw this separately here. Okay, so we're going to draw a diagram here, just with less information on it here. Okay, so say like that one gets further. Oops. Anyway, we have an acute triangle here, okay? All right, so we have, again, so this is where the south compass line is. So this one is traveling 75, sorry, this isn't to scale, and this one's going 55, okay? So 55 degrees from, like, this is the south compass line, and so that's 75 there, and we know that, so this is, I don't know, the boat that went westwards, it's traveling at 15 kilometers an hour, okay, and this one is traveling at 12 kilometers an hour. All right, and we're going to check at the 4-hour mark how far apart they are here, okay? So in order to find this, we need the length of the sides here. So we need the length that, how far they traveled. So we know that the time is 4 hours, and we've looked at speed a little bit already. So if we wanted to even just build that table again, just to kind of organize our thoughts. So ship, I don't know, we can call it A and ship B. Okay, so we know that the speed, okay, so the speed was 15 for this one. So ship A was the one that's going, 55 degrees. Okay, ship B will be the one that's going 75 degrees, okay? All right, so this one's going 15 kilometers an hour. This one's going 12. So we know the time was 4 hours, right? So 4 hours. Okay, so the distance that they traveled, okay, so this was back from before. So distance was always speed times time. That's what we did when we were building our linear equations and so forth, okay? So if we were to just calculate these out, okay, you'll find that they traveled, because this is hours, and this is, kilometers per hour. So in 1 hour, they can travel 15 kilometers, right? So for them, they can get 60 kilometers from the initial port where they started. So if you can travel 12 kilometers an hour and you travel for 4 hours, you can get 48 kilometers, okay? So even if you don't want to use this formula, you can kind of sort it out that way, okay? So what we know here then is that ship A traveled 60 kilometers and ship B traveled 48 kilometers. Okay, so we know this distance, we know this distance, we know this angle that ship A made was 55, we know this one that ship B made was 75, but together, hopefully you guys see that this equals 130 degrees up in this corner. Okay, so if we add them together, okay? All right, so we know this angle in here. We know the sides, so what do we have in the end? We have a side, we have an angle, and we have a side. And we need to find that last side. So what do we need to do when we have a side angle side? Another cosine law. Okay, so I'm going to set up the triangle here. And so we'll draw it a little nicer down here. So we have 130 here. We have 48 here. And we have 60 here. Okay, so what we're going to do is, again, and then we need to find this. So we're going to call this one A, B, C. So this is little a, this is little b, and that's little c. So we're going to use the cosine law here, using this formula here, in order to find how far apart they are, which will be this length right there. Okay, so go ahead and calculate this out. Okay, so I went through and I placed everything into where it needs to go, calculated it out. Here, again, you square root it over, and you get 98.01, 2533, etc. Okay, all right, so in the end, you found that the boats are 98.0 kilometers apart. Okay, I guess it doesn't say what to round to here, but that's what they would be after 4 hours. Okay, so again, a little bit more challenging one. It's kind of more of like a physics type question that you'll see a lot next year as well. But I just wanted you to kind of get comfortable with these directions and so forth, and how you can apply the cosine law as well. Okay. All right, example 4, last one here. So we have a weather balloon directly between 2 tracking stations, okay? So the angle of elevation of the 2 tracking stations are this 55 and 68. If the tracking stations are 20 kilometers apart, determine the altitude of the balloon. Okay, so we have some angle of elevation type questions here. So just here's the balloon, straight up in the air, and we have a couple tracking stations. There's one, so call it station number 1, station number 2. Okay, so remember angle elevation, so it's all about starting at the horizontal like this and then looking up. Okay, at something, looking up and looking up. So if we're looking up like that, so one of the stations is 55 degrees, the other station is 68 degrees, we know that, okay, so it's between the 2 stations, and we know that the stations are 20 kilometers apart. There we go, and that's all we know, right? We know it's just directly between them. We're looking up 55, 68, and 20 kilometers apart. All right, so what do we have here? Well, if we just kind of take away all the other information here, so we have 55, we have 68, and we have 20 kilometers. And I want to know the altitude, which is right in here, okay? So right now, well, we do have an acute triangle here, a non-right triangle, and we need to determine this altitude, which is straight up, okay, at 90 degrees. this problem here, okay? All right, so what we can do here is, well, if you're looking at it and you're like, okay, that's an angle, that's a side, that's an angle, you can use the sine law for something. Okay, so sine law. So what can we find with the sine law? Well, we could find, one of these side lengths. Okay, doesn't matter which one. I guess we can find them both. And then if you found the side length, so say we'll call it y. We'll call it y. Okay. So say if we find that side length there. So then what happens when we find this side length is that we'll have a triangle that has a side and an angle. And so therefore we could find this one. So here, why don't I call it y? Or sorry, no, I already have an x there. So that's how we'll find our x here. Okay, so we can use SOHCAHTOA to find that last side. Okay, if you decided, oh no, I like the right side better, so like that, you could do the same thing here. So you could use the sine law to find z, find this side. Okay, and then once you find that side, you can take it apart and just look at it as a smaller triangle, and then you can use SOHCAHTOA again in order to find the x, this height here. Okay, so it's up to you. I'm just gonna, I guess, use the left side here. Okay, so just go through the steps here. So first we're gonna look at, so this is given. Thing that's required is x. We're trying to find the altitude. Okay, and our plan here is I'm going to use the sine law first. Okay, and then I'm going to use the SOHCAHTOA here next. Okay, so in order to use the sine law, I need to label my triangle appropriately. All right, so again, I'm going to find this side here, right? So y. So I'm going to call this A, B, C, it doesn't matter though. So this is little a, this is little b, and this is little c. Okay, but we're using the sine law here, and I need to find a side, so I'm going to use this formula here in order to get to the information I need. Okay, so we're going to plug it in and calculate out y, and then I'm going to go through and then find the x value here. Okay, so we took our sine law, so you're stacking up this equation here, plugging it in, and then you notice that, oh wait, actually you can go and find c, right? 180, subtract these two makes 57. So then when you go through and fill it in, you know this one here, the top and bottom, so you're going to equal that to your y, which is what you want to find. We don't need to find b here, okay? We don't want to find it. So, so once we get to here, we just equate these two together. I'm going to take this, which is divided, and chuck it over here and multiply it here. So that's what this is. Go through and calculate it out properly. Make sure you're in degrees, and then you get to here. Okay, so that is now the side here. Okay, so this side here, which is 22.1. Okay, so now that we know that, so what we're going to do from there is, now that we know a side and an angle, we're just going to look at the right triangle here and use SOHCAHTOA. Okay, so we wrote 22.1 here, 55 degrees, and then we're going to find the altitude, okay, how high that air balloon is, okay, or weather balloon, sorry. So we're going to use SOHCAHTOA here. We figured out if we stand here, opposite and hypotenuse, we don't need to know adjacent, so we're going to use the sine ratio. Plug it in, calculate it out, and then we found our altitude. Okay, so multi-step question. You needed both the sine law, and we also needed the sine trig ratio. Okay, so the primary trig ratio here. So yeah, just kind of have those ready to go for any of the practice questions here that you are going to try today. And then try the checkpoint, okay? And then, yeah, give yourself a pat on the back. You've gotten through all the tough stuff this year.